Okay. All right. So what's up, everyone? This is part 4 of Hack School. So this workshop will be our first full stack workshop. We'll be teaching Express and APIs and how to use them in React. So we'll be making the APIs in Express and Node.js and then consuming them in React, as well as teaching other stuff in React. So let's begin. All right, so yeah, just a recap of what we learned previously. Last workshop, we learned what React was. So React is one of many front-end frameworks built in JavaScript, and that allows us to build dynamic user interfaces. What this means is that we have user interfaces that can change state based on the user input or based on events that happen. So these happen through components, which are independent and reusable pieces that compose the user interface. We can have separate components and we can reuse them really, really easily with React, which is a huge plus. Like it mentions, each component has its own state and that controls how it's rendered on the page. And since it's independent, we can tune certain components and not others and still have our full application functioning. So for an example component, we walked through this last time. But here's the infrastructure of a component. We declare it with a function. You can use arrow notation or just standard functions, but we use arrow notations. And we pass in something called props. So properties, we learned are certain variables or certain properties that we can pass down from parent components to children components. So we can access certain variables of these properties by referencing them by props dot and then the variable name. So again, we also learned that we can only return one DOM element. So that's why everything needs to be wrapped inside of a div. And yeah, this other than that, the return is basically all HTML, but it's written in a language called JSX, which allows us to inject some JavaScript into it. And to use our components, we need to import them. All components need to be imported from their files. We also need to import CSS, and we can use our components like we normally use with other HTML elements. So the first food cravings, we don't pass in any props, we just declare it. But then the second one, we pass a property called text that has the factual statement tapx number 1. All right, so that brings us to APIs and Express for this workshop. So before I go into how APIs and Express work, I do want to give a high-level overview of how the internet actually works and how we're going to be able to communicate with our API. So at a ridiculously high level, the internet is just a very long wire. So computers will interact with each other by passing data through this wire. They pass data called packets, that's what it's called, from computer to computer, and that's how all interaction between computers happens. So we have clients and we have servers, and clients will request data from servers through this wire. So a client refers to generally just the end user, right? So that would be us. But when we refer to a client, we generally refer to it as a web browser. So when you're on like google.com, like the Chrome browser is the client. And we have our server, which is just any computer that serves and provides data to a client. So we're going to be making a server today in Node.js. And how they communicate is using HTTP. So HTTP stands for Hypertext Transfer Protocol, and it is basically a language that clients and servers can communicate in for them to be able to use requests and responses. Any questions? If there's any questions along the way, feel free to put them in the chat. All right, cool. So let's talk a little bit more about HTTP requests and responses. So like I mentioned before, clients can request for data using an HTTP request. So what is an HTTP request? Well, this request is basically, it's a request to the server to provide something, right? And we can define different functionality for the server to provide through request methods. So the standard for HTTP request methods are get, post, put, and delete. And these each request different functionality from the server. So for get, if we make a get HTTP request, that is a read request. So I kind of messed up the ordering here, but get is reading, right? You're getting data. You're getting data from the server, so it's a read operation. Post is a create operation, where if we send a post request to a server along with some data, then that server can create a resource with that data, generally inside of a database. Put is an update function, where if we send an HTTP request with a put method, and we'll teach you how to actually send these requests and define methods later on. But if you send a request with a put operation, then that is generally going to update some resource inside the database. And then delete is self-explanatory, is to delete some resource. So when the server receives this request and processes the data accordingly, it needs to respond to the client. And this is done through an HTTP response. So with a response, the server can respond with different status codes to signify the response state. If it was a successful response, if the resource that they're trying to access is not found, for example, for 404, 200 is generally a good response. That means everything was successful. Or if there was some error in the server, then that's a 500 response. And you can look up all the codes for status codes in the link over there. So yeah, question, what does post do again? So post is for creating. So generally get is read, post is create, put is update, and D is delete. And these operations are called CRUD, is create, read, update, delete. So when people mention the phrase CRUD, it refers to those four main operations. Okay, so let's have a look at some HTTP requests in action. So generally every website will have some request and response going on, but we're gonna have a look at hack.acmucsd.com. So let's hop over to this website. So how do we see what HTTP requests are happening? Well, we can use Chrome developer tools, and you can do Control-Shift-J or Control-Shift-I to open up the developer tools on Google Chrome. I'm unsure how it works on Firefox or Safari, but you should just use Chrome anyway because Chrome is master race. But yeah, we have our ACM hack website here, and during our second workshop and third workshop, we interacted with elements and console, right? But here we have this tab over here called network. And can you guys see my screen? I just want to make sure, like, is this good? All right, we're good. Cool. So yeah, we have a network tab here, and we can see there's a whole bunch of jargon over here, but what we want to care about here is the actual request happening. So here, there's only one request label. It's like a React Dev Tools, but we need to refresh our page in order to see the request. So here, there is a lot of requests happening, but let's try to break this down. So all these are HTTP requests, and you see all the status codes. So the first request is for the website, is to fetch all the HTML for the website, right? And 304 just means that the resource that they're trying to fetch is unchanged. And this is generally used with a cache, like caching your browser cache. Like that way the client doesn't have to request from the server like so many times. You can just store it temporarily in a cache and just fetch from there. And that's like some system design stuff that we can get into later. But over here, we have a bunch of JS and CSS files that the client has to fetch. And this is all provided by React. Like React provides all these CSS and JS files. So there's a bunch of SVG, CSS, JS files. The SVG is just for the logos. But over here, there is one particular request, this one. And it's actually a request to our own ACM membership portal API. So here's the URL that it's fetching, and it's fetching all the events that are from ACM Hack. And we can see if we scroll down here, we have the events, ACM Hack events, and this is a scuff dev team, I swear moment with the CSS. But maybe one of you can fix the CSS later on, because you should know how to do this now. But yeah, so here is the main an HTTP request that we're going to be using. Similarly, is to fetch data from our own API. So we're going to be making our own API. This is the ACM UCSD membership portal API over here. And we can see we got a 200 response with the request method get. All right, let's move on. And any questions, just feel free to put them in the chat. So yeah, I now want to talk a little bit about a standard web app architecture. So in pretty much every web application, like every web application in the world, there are these three main components. We have the client, we have the server, and we have the database. So the general workflow, or the general flow of data, is when you hop onto a web application or a website, the client will make an HTTP request to the server to get some data, right? In our case, for hack.acwsd.com, the request was to get all the hack events, right? So an HTTP request is made to our server, right? That server will then process that request and see, okay, what do I actually need to get from the database? So it figures out that, oh, we need a community, the committee needs to be hack, and we need exactly 4 events. So then it'll, after processing that, it'll make the database query and then get all the queried data back. Once the data has been queried back, it'll process the data format in such a way that the client will understand and then send it back to the client. And then that is how all the events are being displayed on the hack website. First, the request is made, a query, database query is made, the query returns, and a response is provided. And you'll notice that this is a standard infrastructure for like every web application, like Google, like all the big tech companies, like every company like uses this architecture. So in comes the API. So the API is the middleman, is the bread and butter of our server that makes this communication possible. So what is an API? An API stands for Application Programming Interface, and it sounds like a bunch of jargon, but basically it's just a toolkit that someone is providing for a client to interact with. So an API is a very general term. It can refer to, for example, a Google Calendar API where like Google developers created a bunch of methods, like a bunch of functions for you to use inside your application to integrate with Google Calendar. So it could be a bunch of functions like for example, there's like email APIs where you can send emails within your application, or it could be a bunch of API routes. And an API route is a route on a server that is accessible via an HTTP request. So I see a couple of questions. Yeah, so what is the difference between server and database, and what is a query? Yeah, so I think Daniel answered that, but basically a database is the location. It's basically where all the data is stored. Like all your event data is stored within that database, and the server is what does all the processing that allows that data to be queried and manipulated and returned to the client. Yeah. And then a query is just a database query, like reading data from the database. So yeah, we talked about API routes, and a REST API, which is what we're going to be building, is basically a collection of API routes. So we can have a look at some API route syntax. So here we have two main parts. So we have the actual web host and the port. And the port is just a specific location on the host that you can use to define like where exactly the API is. Like 5,000 is an arbitrary number that most APIs happen to use, but you can use any number really. Like 3,000, 8,000 are also common ones. And then we have our route. So here's the API route, and this is what we're going to be building is /API/Pokemon. So you see, this entire thing is a URL. It's like a standard URL that you would connect to like on your browser. But if we make a GET request to this particular URL, then we would expect to get all the Pokemon that are in our database once we make our database. That's what the functionality will be making, is that when you make a GET request to this URL, we'll fetch all the Pokemon in our database. And sending a POST request with the request body to this route would create a Pokemon. And that's what we'll be doing this workshop and next workshop. So we can have a look at an example API and an example documentation. So we have two examples here. The first one is a random number generator API. So this is a very, very simple API. Basically, you make a GET request to this URL, and it just returns a random name. That's basically it. And one thing to note is when you access something in your browser, that's automatically a GET request. So if I type enter here, that is making a GET request to this URL. There's no real way to make post requests through the browser, and that's why we need Postman or other tools for that. But yeah, you can see every time we access this URL, we get a different name, random name, between 4 and 16. And these are called query parameters that we can pass in to kind of define this functionality. So this is kind of a boring API. We can look at a spicier API with the Imgur docs. So Imgur is like a image hosting website. And we see here's an example documentation. So what Imgur provides in their API is basically allowing you to manipulate and read comments, images, albums, galleries. So we can look at comment, for example. This URL, for example, in this documentation, would allow us to get information about a specific comment. So we would need to provide a comment ID, like we could copy and paste this URL, but into our browser, but we don't really know like what a comment ID is. So there's no real way of making this. But this is an example of like how an API functionality works, right? For post /3/comment, we would create a new comment and return the ID, right? And then for delete, we can delete a specific comment by its ID. And then you can get replies, etc. Real question, is it Imgur or Imgur? That's a GIF versus GIF moment. I say Imgur, but I honestly don't know, man. All right, so now that we know about APIs, let's talk about what Express is. So Express is basically a web application framework that we can use with Node.js that allows us to start our own server and create our own API routes. And we can do all this in 3 lines, right? That's the beauty of Express, is it abstracts away all the complexity of actually serving a web application into just very few lines. And yeah, I think Daniel mentioned a note on API. So yeah, basically an API is like a toolkit. Like when a user needs something, they use something from this toolkit to get the functionality that they need, right? If I need to get all the Pokemon from a database that exists, then I will go to my API and request for all the Pokemon with a GET request, right? And if I want to create a Pokemon, I use the API, sending a post request to create the Pokemon. And it'll make much more sense once we go over it and actually code it. But you can see this is how we actually set up a server, and we will be doing that right now. So this is a live demo. Everyone should get out their projects to the root directory, and we're going to create our own application right here, our own backend. So I have VS Code open here. Everyone should have the code from part 3 all ready to go. So everyone should get to this screen right here if you have VS Code open. So take some time for that. All right, so assuming everyone has their terminal open on Hack School Fall 20 or whatever you named it, and this is what our directory looks like. What we're going to do is we're going to create a server. So we'll do that by creating a new directory called server. And in this server, we're going to initialize a Node.js application. So what we want to do is, well, we can first create a JavaScript file. So we'll create an index.js. And generally JavaScript files, like default name is index.js. That's just naming conventions. But yeah, what we'll do is we need to initialize a Node.js application. Kind of like how we did in React, there's a much simpler way to do it for specifically Node.js applications. So what we need to do is navigate to our server directory. And we can do that using the cd command. So you can do cd space server. And now we'll be in the server directory. All right, so if we do ls, then we should see our index.js. And ls just means the list of files. So now everyone has Node.js installed. So now we need to create a Node.js application. So what we want to do, I can scroll this up here. We want to do npm space init space -y. So what this will do is it'll create a new Node.js application for us. And the -y just means to say yes for all the config that it wants. So hit enter, and now we should have a package.json. So package.json defines the metadata for our application, such as like what the name is, the version, scripts we can run, who the author is. And when we say -y, we just default all these to the default because we don't really need to set this up. So the command is npm space init space -y right here. All right, cool. So now we need to install Express. So we can use npm to install Node.js packages. And again, to answer the question for why, yeah, it just means make the package.json with all default options. Like otherwise, you need to specify the name, specify the version, specify the description, like everything. And we don't need to do that. All right. So now let's do npm space install. And now we want to install a couple of dependencies. So we're going to install Express space NodeMon, and NodeMon is a development package that we'll be using to make our workflow a lot easier. And we'll use that in a second, and you'll see what that is. We also want .env to work with .env config files, and I'll explain that also later. And we also want cores. So these are the 4 packages we need. And I can copy and paste it in the chat. But yeah, this is the command you want to run. So we're going to run this.
Are you sure? We want --save.
Huh?
We want --save.
Oh no, so we don't need --save because npm above version 5.0, you don't actually need --save.
Oh, actually, I did not know that.
Yeah, that's the thing. Me and Maggie figured that out like 30 minutes ago.
Oh, wow. Okay.
But yeah, our package JSON is created with all the dependencies. All right, cool. So we have our dependencies, and now you can see we have a node modules folder. So this folder is freaking huge, and we don't want to commit this to Git or anything because this is like a large ass folder. So what we can do is create a git ignore, but that's not how you spell ignore. Rename .git ignore. And what this will do is when we push our project to GitHub, it won't push the node modules file. So go ahead and save that there. All right, so now we have everything set up to create our application. So let's create our application. And this is boilerplate code that we need for Express. And don't worry, you don't have to memorize any of this stuff. But I'm just going to do the 3 lines that we did. So we want const express equals require express const server equals express, and then server dot listen 5,000. So this is all we need to set up a server. So I'm going to do one more thing before I start the server. The listen function takes a callback, and a callback is a function that we pass into a function again. So this is a function, and we're just going to console.log server started on port 5000, just so that we know the server started. So once we all have this, what we can do is hop into our terminal, and we need a way to run this file, right? Node will allow us to run this file. So what we can do is do node and then index.js. And we hit enter, and we see server started on port 5000. Okay, what does this mean? So we can hop over to our web browser, and let me hide this thing. All right, so yeah, we can hop over to our web browser and go to localhost 5000. And now we see this. We say cannot get slash. What does this mean? So it means something is running on our local host, right? Because normally if you go to like a different local host, like 5050, then nothing will load. But we have something loading on 5000, right? Refuse to connect. which means it's working. So cannot get slash. Well, we know what this means. We just learned it. We can't make a get request to just slash, and slash refers to localhost.5000 slash, and the slash is implicit. So these are the same thing. So what we need to do is create an API route, and we'll go over that in the next slide. All right, so how do we create an Express API route? Again, this is 3 lines. This is why we love Express. We want to define a router variable that's express.router, and then we can do router.get or router.post, router.put, whatever, and then have the route name, and then a callback function with the request and a response. And then what we need to do is we can perform our business logic. We can do whatever we want to fetch Pokemon from the database. But at the end of our file, or at the end of our function, we want to respond to our client, right? And how we do this is we do res.status of 200, which is okay, .json, and then our Pokemon object. Okay, so let's actually make this route right now. And let's experiment with API routes. So there's a couple other housekeeping things we need to do to make this code clear. Let me hide this again. Okay. So we have this right now, and we have our server running. So let's shut this off for now. You can shut it off with Control-C. If you're on, I'm pretty sure that works for Windows, Mac, and Linux, or maybe it's Command. I don't know for Mac, but yeah. So what we want to do is define a router, right? We have our router here, and we can see router is type router. And then what we can do is router.get slash, and we can do slash for now. We can do Pokemon later, or we can just do Pokemon right now. Slash Pokemon, and then we have our request and our response function. So this is a function, an arrow function that takes in a request and a response. So you can see the types if you hover over. Rec is a request with a dictionary, some large thing, and then our response is our response. So what we can do is do res.status 200.json, and then we can have a JSON here. So this is just standard JSON. We could do like hello world. Right? Don't forget your semicolons. And here we have an API route, right? This is a router that creates an API route, but we're not done yet. You can see that if we node index.js, this doesn't work. But if we do slash Pokemon, it also doesn't work. So what we need to do is we need to register our router to our server, and this is very simple. We just do server.use slash and then router. So what this does is it registers the prefix, the API route prefix of slash to our router object here. So slash again refers to the prefix, and if it's just a slash, it's implicit, so it doesn't need to be there. But what we can do now is, well, we need to restart our application every time. And we have an error here. Server is not defined. Oh, I defined them. Oops. We can define this up here. No index.js. Let me see this. And if we load this, we see our hello world JSON. And here I just have a parser extension, but this is what it should look like. We get hello world. So what we can do is, since we're exposing an API, what we want is a prefix of API. And if we do this and then restart application again, and you can see this restarting our application every time is kind of annoying, but we have a fix for that. We do now, if we do slash API slash Pokemon, we get the same result. And if we do just slash Pokemon, then that doesn't return anything. So this is the route we want, right? And what we can do now is we can fix our code a little. So this code is all functional. It all works, but there's a couple of things wrong with it, right? One main thing is this restarting. And this is why we have NodeMon. So we installed NodeMon. What we can do is define an npm script that will use NodeMon to start our app. So normally we do node index.js, but we can create a script called dev example and do NodeMon index.js. And we'll also define a script start to do just node index.js. Now what we can do is npm space run space dev, and this will run a script that we define here. And we define dev as a script. So we can do npm run dev, enter, and you see NodeMon kicks off. So there's a bunch of output here, but all it's saying is it's listening to the file. So if we make a change, let's say I remove a semicolon and I save, it'll automatically restart. So we don't need to keep starting and stopping it again. Okay, so there's a couple other things wrong with this code. Like functionally, this code works. And I have a question here. We don't actually use request. We're not using request in our get method here. A, because it's very, very simple, like we're just returning something. And B, for post requests where we have an actual request body, we'll be using our request object there. But you can see request has like a bunch of fields here, right? Params, body, creator, URL. But we're not using it for this simple application. So there's a couple of things wrong here. And one of them is we're defining this magic number here, right? We have a magic number 5,000, and it's some type of config that we're just hard coding here. And we don't want to be hard coding that because let's say we have other developers working on this project and they already have stuff on port 5,000. If we define that they have to use port 5,000 here, then there's a problem and they'll have to edit the code and then make sure that they don't push the code. And it's all chaotic. So let's be smart developers and make this configurable. So how do we make this configurable? Well, we installed a package called .env, and .env allows us to use what are called environment variables. So environment variables are variables that we can define in a file called .env. So everyone should create a .env file, call it .env, and then enter. And we can set variables here. So we can define a port as 5,000. And we won't be committing this file to our GitHub because we want other developers to be able to configure it themselves. Like we don't need to hard code 5,000. So what we can also do is create something called a .env.example. Right, so this is our config. We don't want our config to be visible to other people, right? Because they could have different configs. So let's create a .env.example and show up VS Code. And we can just have it port equals and then blank. So everyone should create two files, .env and .env.example, where you just have port equals and then a blank number. And then for .env, we just have our defined as 5,000. We can close those out. And in our git ignore, we should git ignore our .env so we don't push that. So now what we can do is we can create some config. So we have this magic number here and we want to get rid of it. So let's define a config folder which will store all the configs to this application. And it's very simple. It'll just be our port and then our database URL, which we'll create later. So let's create a folder inside server called config. That's config. Config, yes. And let's create a file inside there called index.js. So you should have config and index.js inside server. So now we can use .env. So let's import it like we did with Express. So const.env equals require .env. And yeah, the get ignore should have .env. There should be a file ignored there. Yeah, if it's at your root, then you want it to be server in.env. Okay, so now we can access .env, and there's a function called config, which basically loads all these environment variables into this application. So that's just something that you have to know for like just as setup for config. And yes, you can have multiple git ignores. And there's no point in having them in the same directory, but you can have them. You can have one for client, one for server, and it'll ignore specific files within those directories. But if you have one that is at the root of both client and server, then it'll ignore everything in both of those. If that makes sense. So like, let's say I have client and then index.js and then server and then index.js. If I have a git ignore at the root that ignores index.js, it'll ignore both of those. But if I define one just here, it'll ignore just the server index.js. So let's create our config, config, and we'll just create this as a variable, and we can have our port be process.env.port. And we're going to export this config. And what we're going to do is we're going to import this config into our index.js. So everyone should have a config object, which is just defines port, and it's all caps because it's a static constant variable, right? It'll never change unless we like manually change it. So we can hop over to index.js. Config is equal to require /config. And then once we import it, we can have config.port. And then here we can do port plus config.port. So you can see it's still 5,000. Even have the number 5,000 anywhere in our code anymore. Okay, so let's do one more thing and then we'll have an activity. So another thing you'll notice here is we have our API definition and all our boilerplate for Express in the same file. And yeah, let me hop over to config. This is the contents. So it's just a JSON with port and process.env. So one good practice for software engineering is layering. So when we talk about layering, we mean each layer of an application should do just one thing. So this is the root layer of our application, which is just like the server root. Like this is just our root of the server, but it's doing multiple things here. One, it's creating an Express app and it's defining an API route. And that's two different things. And sure, it works fine with just one API route, but if we start getting like tens or hundreds of API routes, then this one file becomes really freaking huge. So what we want to do is we want to move the contents of this API into a separate file, and that's what we'll be doing right now. So let's create a folder inside server called API, and we'll create an index.js in there. And what we'll do is we can move this server up here, and what we can do is just copy all this, the router code, into our index.js, and we have to define router. Yeah, so const express. Right, so we have our router here, and then we need to export it. So we export variables with module.exports in our Node application. And here we don't have something, we have nothing called router here, so we need to import it. Router equals require API. Right, this is how we import it from our API file. And again, The good thing about index.js is we don't actually need to do API/index. This is what's happening under the hood, but we can just do /API. And since it's index, then all we need is this. So this file looks a lot cleaner, and it should have the exact same functionality, right? Exact same functionality, and is doing just one job. So if there are any questions, feel free to drop them in the chat. All right, so now let's actually return some Pokemon. So let's define a Pokemon equals, and let's create a Pokemon. So we can make this an array, a JSON array. So we want to return multiple Pokemon. And okay, so we're getting some questions. So what if you have multiple? Anish, I'll answer yours later. But what if we do have multiple routers under API? Well, if you have a file here like Pokemon.js or like trainers.js, then you would just import those again. Like import like router as this could be like default router, and then you can have something like const like Pokemon router is equal to require API/Pokemon. If you want to have multiple. So let's undo all this. Okay, so let's create some Pokemon. So these are JSON objects, right? So we want to have a name. I could do a Pikachu. We want to have a type 1, or we can have a description first. The Pika Pokemon. And you can name these whatever you want. You don't need to follow me exactly. Type 1 electric. Type 2 null. What are we missing? Power. Or moves. Right, moves. Oh, we have image too. So for moves, again, these are more JSON objects, so it's an array of JSON objects. And we'll have, for moves, we can have a name, a type, and a power, right? So I want a name as like scratch, type as normal, and power as 30. So yeah, we just have one move for now. And then for image, each Pokemon we want it to have an image, right? That's how we're going to be displaying them. So for now, we can just link to like google.com, but we'll be having actual images later. And then what we can do is JSON return this Pokemon. And the reason we don't need key value pairs here is because this implicitly will do Pokemon. So the key is the name of Pokemon and the value is Pokemon. But if they're the same thing, then all you can do is just have that. So now we can hop over, refresh, and then we see our Pokemon. And this is parsed, but it'll look like this for raw. If you're curious, it's JSON formatter. It's usually useful. Okay, and let's define one more Pokemon before we move on. I just a long walkthrough, but we can define one more Pokemon. So let's define Snorlax, the Chad Pokemon. We just leave it as Google. Surf. Cool. So now we have two Pokemon. If we just refresh, now we see Pikachu and Snorlax. So this is the format that we're going to be returning data to for our clients to use. All right, cool. So that is all for our get Pokemon route. So we're done. We created our first API route. Once we have a database, we'll be querying our database for this, but for now, we're going to be hard coding data here. All right, so let's hop back to the slides. All right, so for post request, we can do a very similar thing. So for post request, well, since we're creating something, we need to be able to send a data to create, right? The server needs to be able to create something, and we define that data as our request body. So you can see in our slide here, we have const Pokemon equals request.body.Pokemon. So we can access any data that we send with request.body or rec.body, right? And we can get our name by Pokemon.name, assuming we send a JSON with this exact format, right? So we have Pokemon and with the field's name description, right? So we also, if you see the third line, this is called object destructuring. So assuming Pokemon has the fields name, type 1, description, type 2, image, move, you can do const and then brackets or curly braces, description equals Pokemon to create a variable called description equal to Pokemon.description. So for name, we could do const curly bracket name equals Pokemon, and that'll do the same thing. It's just a JS trick. So how do we actually send data to our API? So this we'll be using Postman for. So Postman will allow us to send requests to our server easily using creating our own requests. So we'll be using Postman to test our post Pokemon route. So everyone should have Postman already. You should see some screen like this. So everyone should get out Postman and have that.
Are you sharing real quick? Can you paste the post request portion of your live code right now? I don't know.
Yeah,
I think the one you just made earlier in the live coding, or no?
Sorry, which slide?
What up? I think Anish. Oh, the part where you added, sorry, the part where you added Pokemon in the live coding portion.
In the code or the slide?
In the code. Yeah. I didn't see you added it in the code. Yeah.
What's up?
Yeah, can you just paste that?
Oh yeah, like this Pokemon?
Yeah.
I'll post it in the Zoom and someone can move it to the Discord.
Yeah.
All right, cool. So once you have Postman out, we can create a request. So click create request. And what we can do is we can specify our type. So we'll make a get request to, we can actually just request what we just had. So we have this port on localhost. So we can make a request to HTTP localhost 5000/API/Pokemon. So if we make a get request here, then we'll get the Pokemon that we just got, right? So here's our exact Pokemon we've seen. So with post request, right? So all we need to do is change this to post, and we haven't defined this function yet, but what you're going to be making, you guys will all be making the post route in our next activity. But just in advance, when we send a post request, we need to define a body. But in order to define a body, we need to tell our server that we are sending data. Like we need to warn our server, like, hey, we're sending data, and then send them the data. So what this means is we have to define a header. And it's just a simple header that's content type to app.json, application JSON. So specify this in the headers. That'll make sure that the body, the server knows that they're receiving something. And then we can specify, if we go to raw, and we see we have JSON. Now we can create our own Pokemon. So here, this would look something like this. So we have our Pokemon object, and I'll paste this in the chat as well. But here we can create something like name Squirtle. We'll make this image actual thing. But yeah, and also don't worry about copy and pasting all this. Or copying all this right now. I'll paste in the chat. but we want to define a name as a wing attack. So let me copy and paste this. So our job, our goal right now is to be able to process this data. So that's our task for now. So let's continue on. And now we'll be creating post Pokemon. So this is a task for you guys. What we're going to be doing is creating a route called post/Pokemon, and then we're going to define this functionality. So you're going to return an error response and the proper status code if the user doesn't pass in all of the following. So name, description, type 1, type 2, image moves, or if the user passes in more than 4 moves. And then if no errors occur, if they pass in all this, then return a response with all the moves that have the word punch in them. So if I send a Pokemon with the move like wing attack punch, it should return that as a move. So you want to return all the moves, okay? Not the actual Pokemon. In reality, this would be like a database creation, but we don't have a database yet. So let's do it. This is our activity.
We'll be in the Discord in the live.
Yeah. Actually, okay. So there is one more thing we have to do, and I'm gonna hold up real quick. But we do have to define. We have to allow Express to be able to process our inputs, and that's something I forgot to do. But this is just a one-line thing. What you want in your index.js is server.use express.url encoded, and I'll paste this in the chat. But this is something we need to define so that Express can access and parse our JSON input. And we also need to enable cores. So I'll paste this. And this is something we need. Oops. Oh, we have to define cores, right? So cores is another package that we imported. So, and this is needed to allow our client to talk to our server. So I'll paste this. So everyone should have that, add that. That is not Zoom.
How long do you want this activity to be shown?
Huh?
How long do you want this activity?
Oh, let's do like maybe like 5 to 10 minutes. It should be pretty fast. And I can hop in the Discord and.
Okay. I think it'll take a little longer, but okay, we can do 10 minutes.
Yeah, I kind of took it too long.
Yeah, you're good. Okay, we'll be in the Discord, everyone.
All right. I can just continue.
Yeah, go for it.
Are we good to continue?
Yeah.
All right, cool. So yeah, so here's our index.js. We did need to include express.json. I think that's something I forgot to include earlier. But this allows us to process the request bodies. So everyone make sure that you have this line of code. But for our solution, I can delete this file. But yeah, here's our solution. So we basically get the Pokemon object from request body, and then the name, description, type 1, image, moves from Pokemon. And then we're checking if none of them exist or the length of moves is greater than 4, then we return an error with status code 400, which is a bad request. And we return invalid input. Otherwise, we get all the moves, we filter where the move.name includes punch, and we return that. So this is supposed to be like a JavaScript practice kind of thing. Well, it's also Express. But in practice, this file will be like a database creation function. This is just for like JavaScript practice. So yeah, that's it for the code. And I'll post all this in the GitHub solutions. So yeah, let's move on. So yeah, that's it for Express. We created our API routes for get and post, and now we'll be using them in our React code. So Maggie, can you you can take it away? I'll stop sharing for now.
All right. Okay. Let me share my screen real quick. Present. So welcome to React Part 2. So remember from last time, we introduced a very cool framework called React. So just a small recap, that React is a really cool framework that can help us increase code usability. So saves us a lot of code, and it helps us do the automatic window update. And React is a component-based language, which means that a React program is usually made up of many small components, which are building blocks that make up a page. And the components, they can be reused and made different with the props. What are props? So props are like parameters, and they are usually non-changing, and then they can make each component different from each other. So if you remember last time, our example was defining 3 meme song components with different props, and that's our result. So right now, as we are moving on from props, we are ready to dive deeper into React. But first, we need to do a little review exercise. So remember from last time, we created a component for our Create Pokemon page, but there's still one more page for us to do, the ViewPokemon page, right? So ViewPokemon is a component that will currently not take in props. So we'll just have you copy and paste the ViewPokemon.html code into the new component that you're gonna be creating. If you need any help down here, here's a basic outline of what the code is supposed to look like. And make sure to remember to change your class keyword to class name. And when you're done, if you have time, if you can run npm install react router DOM Axios, because these two are the packages that we will need to use in the later parts of the workshop. So right now we'll just hop on to Discord again. I will keep this code up so you all can still reference it when you need.
All right, we'll go on Discord.
Both our pages turn into components, right? But then we notice one thing, our navbar doesn't really work. So what we're doing right now, which I will be live coding, is adding a router to our React app to allow us to switch between pages. So what we do now, as I said in the last exercise, we're supposed to install the React router DOM and the Axios. So if you have not, if like anyone has not done that yet, I will just show myself doing this right now. So you're supposed to be in the client subfolder. So what you do is npm install react router DOM and Axios. It will take a while to do, but it will eventually come. Let me check the chat. Oh yeah, this is the GitHub terminal because, well, I'm not superior, I'm just on Windows. I'm lame. So our live coding session for this part is mostly going to be focused on React router DOM, and Axios will mostly help us with interacting with the API, which we'll get into later. So with Axios, we can interact with our server that we just set up in the backend part of this workshop. Okay, honestly, is anyone else's like React router DOM and Axios like installing? Like, how's your installing going?
This is why Yarn is master race.
Yeah, well,
Yeah.
not everybody has Yarn though, so that's why
Yeah.
I have NPM.
NPM kind of not the best.
Yeah, this is why you don't use JavaScript.
You say this is why you use.
You write your APIs in Rust.
No.
JavaScript, bad.
Wait, Golang server is actually pretty nice.
Yeah.
Okay, anyways.
Writing in Scratch. That's a very nice idea.
Maggie, maybe you can write the code and then maybe it'll be done by then.
Yeah, and probably, yes, this takes forever. That's a good idea. Okay, so right now we have our ViewPokemon.jsx, and if you try to test it, the page should look like this right now. But we still want to like make our navbar component actually redirect us to different components depending on what link we are on. So what we do is right here in app.js, we're gonna import React router DOM, like components from React router DOM. And this line is gonna be kind of long, but don't be overwhelmed. I will be kind of like explaining why we are importing so much things over here. How we do this is we import browser router as router. Redirect, route, switch. All of these from React router DOM. So basically right now we imported these things from React router DOM. One's called router, then we have redirect, route, and switch. Give you guys a couple seconds to type that out. So the next thing we want to do is actually to wrap the whole return statement in a huge router. We can do router. We kind of sandwich the entire app division under our router. And instead of just rendering the ViewPokemon component by default, here is where we can make our routes more dynamic. So remember in navbar.jsx, oh, I accidentally closed it. We have defined two paths. So if we are on create, we should be on the create Pokemon component. And if we're on view, we should be on view Pokemon component. So how we do this is we put a switch statement under our app. And our switch statement is gonna contain one redirect and two routes, but I will be getting into the routes first. How do we specify a route? So we have a route component, and we define the path as path. So let's say we want our create path to map to our create Pokemon component. And then we can specify this by putting component equals to create Pokemon. Oh, by the way, we should still import both components from here because we will still be referencing both these components in our routes. So import create Pokemon from /pages/create Pokemon. Yeah. I need to move my screen sharing bar. And also, we need the exact word at the end so that the exact path create will lead us to create Pokemon. And similarly here, we have our ViewPokemon component, which should be reached with the view pass. So right now we have 2 routes, and then hopefully my code is compiling. If it's not compiling, that's gonna be sad. Okay, so right now what our code looks like on this page is if we go to the create page, we can see create a Pokemon. So localhost 3000/create. And then if we go to localhost 3000/view, we can see the ViewPokemon page. Same thing goes when you click on the navbar, because the navbar basically takes us to different subpages of this application. But if we just type in localhost 3000, we see nothing, which is not what we exactly want, because we want our users, when they visit our website, they can just land our create Pokemon page without having to type in that extra slash. So how do we do that? That's when our redirect comes in play. So what redirect does is it redirects one route to the other. In this case, we want to, oh, I was not sharing my VS Code. That was my bad. So what we want to do right now is we want to redirect our localhost 3000 to localhost 3000/create. How do we do this? So we have 2 properties in redirect that's called from and to that we can define. So right now from will be slash, right? So it's just the home page. It will go to the create page. And just like our both our route components, we will need an exact keyword at the end. So once we save this and we go back to our React application, which is taking forever, by the way. If you type in localhost 3000, it will redirect you to the create page. So now we are happy. We have a functional navbar and our homepage redirects to create, which makes our app like a lot easier to navigate. I will pull up my code again for a while for anyone to see, and then I will check that you guys' questions. I see 4 new messages in chat. $3,000, I think it's defaulted by create React app. So if you do a React app, it's basically usually defaulted to 3,000. Okay, I will stop sharing my screen for now. Wait.
Yeah, we can continue because I'm gonna do the API part.
Yeah, okay. Sherman's gonna take over for API.
All right, cool. So we just finished creating our router, and now we're looking back at our architecture. So we created our server, and now we need to be able to connect our clients to our server. So we finished the server, and now we need to implement the client. So what ideally we want is we want to be able to fetch all these Pokemon and all their images, right, from the get/Pokemon route. So right now there's just hard-coded Pokemon, but once we actually create the canvas, then all these Pokemon will start showing up on our screen, and we're going to implement that functionality. So how do we do API calls from the front end? So using Axios, which is the module we installed previously, we can make get and post requests to our server. So we need to make sure our server is still running. So if you go to the server directory, make sure that server is still running, because we do need that to be running for our client to access that. So we can make get and post requests with Axios. And what we'll be doing is creating a utility file called api.js that will make our API calls. And then we will use the utility function in our ViewPokemon and createPokemon pages to get and create Pokemon. So for a get request, this is what it would look like if we have an api.js file. So we would need to define a server URL, which for now is just localhost 5000. And we would use axios.get. So we could see that our function get meme songs will return axios.get server URL /API/meme songs. So for here, we would just have /API/Pokemon. And a way we can use it in our React code is we could do meme songs equals await api.get meme songs. And we need to await this because Axios returns a promise. And remember, promises are they're basically needed because our API call isn't instantaneous, right? It'll take a couple of milliseconds for the API call to actually be made and all the data to get processed. So we want to await that until it's actually ready. Otherwise, the code will just continue and we won't actually have our data. So to break this down further, we define our URL. We define a API wrapper, kind of like we did with our config in the server, something that we'll be exporting. And we'll define our functions. So we have get meme songs. So this would be like get Pokemon or create Pokemon for us. We do axios.get, and then this fancy syntax is like string injection or something. I forget what it's called, but basically if you use backticks instead of single or double quotes, you can inject variable names into the string. So this $$ curly brace server URL just injects API name.someapi.com. Yeah, template strings, there you go. And we export it and then import it here, and we await it, and we make that call. Post requests are very similar, except we do need to pass in a JSON object. So we'll be wrapping it in our outer function again. So here we have create meme song, and we want to pass in a payload. So this payload is going to be a song in this case, but in our example, it will be the Pokemon object. And we're going to make a post request to the same server /API/memes, or here it'd be, for us, it'd be Pokemon, and sending that payload in. And again, we just await api.create meme song in our React code or our JavaScript code, and then it'll be created. So now let's implement this. So I kind of broke down how we actually want to implement this. We want to create a bunch of functions inside api.js. And we want to use Axios and create the get Pokemon and create Pokemon functions. So yeah, let's do that. It should be very quick, actually. It should probably be like 10 lines of code, or like 13 lines of code in the api.js. But basically, we're going to make api.js. So we can hop over to the Discord calls, and we can spend, we can come back at 5:45. Should be really fast.
A lot of stuff to cover.
Yeah, so we'll be hosting like office hours and like catch-up sessions, and like all the code will be posted. Like I know this is like a very heavy workshop. It's like the first full stack workshop, but
I think whatever we don't get to today, we can always just cover in the next workshop.
Yeah, we can just go over it next time.
Yeah, so.
Okay. So we'll cover as much stuff as we can for this workshop.
Yeah, we can continue to state. We can at least teach state.
Yeah, we can at least teach state for this one, I think.
Yeah.
Okay, so if you guys remember from last time, we asked a question, how can we make our components more dynamic? And one of the ways to do that is by using props. So just just as a recap, props are mostly static and they define a component, but states are usually dynamic as versus to props. So you can treat the states, you can think of them as like local variables of a function, and the React components will always update automatically when one of the states will change. So, well, if you look at the parameters on the right, you can kind of like understand them as 3 parameter components, and then you can see temperature as their state. So why is temperature a state but not a prop? It's because temperature is changing, right? So the temperature does not define what the parameter is, but it is a current state of the parameter. And then we can also like determine what color the parameter is. So for example, we can say if the temperature is below 50 degrees, it's blue. If the temperature is above 100 degrees, it's red. Anywhere in between, it's green. So that's pretty cool. But how do we change state, right? So one of the things that we are going to introduce is event handlers. So event handlers are basically functions, but they only get triggered when a certain type of event happens to a certain element. Well, the kinds of events you can understand them as like your interactions with this page. For example, you click on something, you drag something, you focus on something, you type in something. These are all the events. So some typical events that we're gonna use in a lot of the JavaScript or React programs are on click. So that's when you are clicking on a component, and on change, on focus, and on blur usually has to do with HTML elements. And you can actually define these like state event handler functions in line, but it's better practice to declare them as a separate function because it allows you to reuse these functions and make your code cleaner. So it might sound kind of confusing, but here's an example. So in order to use state in a functional component, we need to import useState. So useState returns an array of 2 elements. So the first element will hold the current value of the state, and the second element will be a function that can change the value of the state. So what we're doing on this line is basically saying that we are declaring a state that's called clicked, and its value can be changed using setClicked, this function, and then its default value will be false. And then this is our event handler function. So its name is toggle clicked, and what it does is basically sets the clicked state to hold the value of the opposite of the current clicked. So you can see the syntax. It's basically in order to access the value of the state, you just say the name of the state. And if you want to change the value of a state, you just use the function and pass in whatever the new value you want it to be. So right here is the HTML element that can trigger the toggle clicked function. We define it using onClick, so this function will be executed when you click this division. And so onClick equals to toggle clicked. That specifies what function we use when we click this div. And one more common mistake that's happening is some people might add parentheses at the end of toggle clicked, but it's not gonna work because if you add parentheses to the end, the function will trigger no matter what. So even without you clicking the division. So make sure to not pass in parentheses when you are referencing to the function itself. So another React hook, so useState is one of the React hooks, and useEffect is another very useful React hook that we can use in basically every React React application. So why is it important? It's because, well, it's a function that runs on initial load and on whatever reloads that you want it to run. So it takes a function as a first argument, and it has an optional second argument of an array. So as use effects usually runs on the first load of the application, it's commonly used to load data on the initial load or updating important document aspects on specific state changes. Also, so the second argument array, it defines which states will trigger the function in use effect, which I can explain better with the upcoming example. So like use state, use effect is also a hook that we need to import at the top, curly braces. So this is the body of our use effect. So our first argument is an anonymous function that loads console.log, right? And then our second argument has non-renders in it. So if you look at non-renders, it is a state, which means use effect this function, console.log, this is a new render. It will happen on the first load of the component, the clickable div component. It will also console.log again whenever non-renders changes. So yeah, as we explained, the first argument to use effect is the function to be triggered, to be executed once use effect is triggered. And the second array will contain whatever state will be able to trigger this use effect. And also, even though the second argument to use effect is technically optional, it's still strongly recommended to define it, because if we don't have a dependency array, it will default to updating, like executing this function on every single state change. So what if we want our function to involve some of state change? Then the React app will fall into infinite re-renders, because the state is always changing, and then it will always call the function again, which doesn't seem to have an end. So we're supposed to have our Pokemon state and use effect in here. Do we have enough time to do this?
I don't think so.
No, let's leave it for
we can push this to next week. Yeah.
Yeah, okay, let's do it for next week. So let's stay tuned for part 5. And yeah, part 5 will be like continuing React part 3 and part 5, and we also have that database.
Trevin, you have anything you want to?
I mean, yeah, we didn't really cover everything in the workshop, and we can do some catch up next workshop for that. So no worries if you don't have all the code. Also, I just pushed all the solution code to the part 4 branch. So whatever code you need, feel free to grab from that.
Yeah, and also we know today was like a big fat workshop with like
full stack, baby.
But honestly, like this is kind of, I mean, I'm sure a bunch of you are like a little bit confused on some stuff, but like honestly, this is the meat of what full stack is. Like you'll be jumping back and forth from like the server and then going to the front end and then going back to the server and back and forth. So we hope like you learned a lot today, and we will have office hours as always every week. Henry has his at 7. So feel free to come out to that.
Actually, I believe I have to change my office hours to tomorrow at, I believe, 4 p.m.
Okay, I stand corrected. Not tonight. As always, we have our calendar, so you want to check that out. Also, feel free to please fill out the feedback form. We are always hoping to improve, so please share your feedback there. And I think that's basically it. I don't think I'm seeing anything else.
Yeah, that's
Okay.
Thanks
Yeah.
for coming, everyone.
Yeah, thank you for coming, everybody.
Yeah.
Hope you learned a good deal.
Well, we hope you learned something, you know.
Yeah.
Thanks for having us.
Yeah, for
Yeah.
sure.
Thank you for